Let's use a 2N2222 transistor. You can draw the characteristic curve of 2N2222 transistor. The emitter goes straight to the ground. Use a DC current and voltage generator for the base current and collector voltage. Select a constant value for DC current. Set a constant value for the voltage generator. Use a voltage probe for the collector current. We need to display three interrelated parameters, namely the collector voltage to the emitter, the collector current, and the base current. Choose a name for the collector current. Select DC sweep from chart mode and drag in the window. Drag the collector current probe onto the graph. Double-click on the title bar of the graph. From the Edit section, select the range of collector emitter voltage changes between 0 and 10 volts. Set the base current between 1 micro and 30 microamps. Press the spacebar key on the keyboard. For a better view, you can change the color of different parts. Assuming a 9-volt battery for the amplifier, we consider the operating point voltage to be 4.5 volts and its current to be 1.5 mA. You can calculate the beta of the transistor. Let's use self-bias circuit for bias the transistor. Select an arbitrary resistor from the library. Set the power supply to 9 volts. Use a voltage probe to measure the collector emitter voltage. With these values of resistors, you do not get the desired operating point. You can use Proteus to determine the amount of resistances. It is recommended to obtain the effect of each of the circuit resistors on the collector voltage. You can use the DC sweep graph. First, the effect of the emitter resistance on the collector voltage. Put a capital X instead of the emitter resistance value. Drag the collector voltage probe onto the graph. Choose the range of resistance changes from 1 ohm up to 10 k ohm. Press the spacebar key on the keyboard. This diagram shows that the collector voltage increases with increasing emitter resistance. Return the emitter resistance to its previous value. Repeat the same process for the other resistors. Choose the range of collector resistance changes between 1 ohm to 15 k ohm. Choose the range of R3 changes between 1 ohm to 100 k ohm. Choose the range of R4 changes between 1 ohm to 20 k ohm. Add a current probe to measure the collector current. Run the simulation. The current is high and the voltage is less than the desired value. To limit the current, we choose a collector resistor of 2.5. For thermal stability, we choose the emitter resistance of 300 ohms. To increase the collector voltage, we can increase the resistance of R3. Decrease R3 slightly. Reduce more. Increase the resistance of R4 to 11 k ohm. Slightly reduce the resistance of the emitter. Let's accept these values. Complete the amplifier. Use the capacitor to couple the signal to the input and output, and bypassing the emitter resistor. Use a 10 kg resistor as a load. Select the sine input with a frequency of 10 kHz and a value of 10 mV. The amount of capacitors must be selected so that they act as a short circuit at the operating frequency. To check the signal without DC, move the probe. An oscilloscope can be used for some measurements. Adjust the ground of the canals to a level for more accurate measurements. Now you can calculate the gain circuit, and also print the oscilloscope screen. For more clarity, you can adjust the color of different parts. Let's use a software to simulate printer. You can calculate the frequency response and bandwidth of the circuit. First, choose a name for the input. From the graph mode, select the frequency graph. Drag the output probe onto the graph, and place it in the upper left corner of the graph. Select the input, and select the frequency range between 1 Hz and 200 MHz. Press the spacebar key on the keyboard. Now, having a frequency response, you can calculate the bandwidth. First, get the maximum gain. Specify the frequency of 3 dB gain reduction. You can also get the phase diagram. Drag the output probe again on the graph and drop it in the lower right corner of the graph. Press the spacebar key on the keyboard. You can determine the effect of each circuit element on the frequency response of the circuit. You can use the AC sweep graph to do this. Drag the output probe onto the graph. Let us obtain the effect of the bypass capacitor on the output of the circuit. Put a capital X instead of the emitter capacitor value. Set the input frequency range between 1 Hz to 200 MHz. Select the capacitance change range from 1 micro up to 1000 microfarads. Press the spacebar key on the keyboard. Frequency response is plotted for 10 different values of bypass capacitor. The rightmost diagram is for a 1000 microcapacitor and the leftmost diagram is for a 1 microcapacitor. Thank you for watching.